Let's see how our 5-value model applies to a different kind of primitive, a cube. A cube is very different than a sphere in that it's very low resolution. A cube only has 6 faces. And unlike a sphere, a cube is a completely hard object, so the edges are going to look quite different. The first thing to do, as always, is isolate the light and shadow families. There they are. And this is because the light source is placed slightly behind us and to the left. Now, unlike a sphere, a cube's planes are placed at 90-degree angles from each other. So when we begin to apply our 5 values, it's actually a very easy process, but it might be a bit misleading to some. Let's start with average light. Where is it? Well, the simple answer is the plane that most faces the light is going to get the average light. And in this case, that's the top plane. The side plane of the cube that's in light, because the light's coming from above, that side plane is turning away from the light, but it's still in the light's influence. Therefore, it gets the halftone value, which again is a step darker than average light. The highlight on a cube is a very misleading thing. You might wonder where it goes. Well, remember the highlight is a direct reflection of the light source. Now, the only place on a cube that can provide the right angle to reflect this particular light source is right where 2 planes meet. So the highlight on this cube with this light direction is placed here. Okay, so now we move to shadow, and these values are pretty simple. There's only one plane that's facing away from the light, and of course that's going to get average shadow, as well as the cast shadow. And then the reflected light is just that bounced light that's bouncing into that plane that I've placed here. Now, how about edges? Even on a cube, we have a variety of edges going on. So here they are. The relationship of these edges is quite subtle, but it adds a real-world believability to what is otherwise a very sterile object.